let's take a look at right triangle trigonometry. And first thing, let's just write down some identities. If we look at sine of an angle, sine theta, is equal to 1 over cosecant theta. And cosine theta is equal to 1 over secant theta. And tangent theta is equal to 1 over cotangent theta. Now, going along with this first one, cosecant theta is equal to 1 over sine theta. And secant theta is equal to 1 over cosine theta. And cotangent theta is equal to 1 over tangent theta. Now this section deals with right triangle trigonometry, and in the process some of these we have to plug into the calculator. And if we look at our calculator, we have a sine, cosine, and tangent button, but we do not have cosecant, secant, and cotangent. So if we want to plug those in, then we have to use these relationships that exist. They're reciprocal. And we'll see what we mean by that here in a second. But those are going to be our formulas. Okay, our first problem. It says use a calculator to find each trig ratio to 3 significant digits. I'm actually going to take these to 4 decimal places. I don't think in homework I say significant digits. Now notice this particular one has a degree mark on it, which means I want to make sure my calculator's in degrees. So I'm going to press my mode button. I want to down arrow the line that says radians in degrees. Right arrow, put my flashing cursor on degree and press enter. Now mine's already selected, but if yours isn't selected, then that'll select degrees. And then I'll do a second mode to exit out. And now I'm going to plug that in. So I got cosine 37.8. So cosine 37.8, and then press enter. And the 4 decimal places, we got 0.7902. And that's our answer. Now our second problem. We got cotangent of 41.2 degrees. Well, I don't have a cotangent button, but I know that cotangent I could rewrite as 1 over tangent by this this property, this identity right here. So I can rewrite this as 1 over tangent 41.2 degrees. Now it's again degrees, so I want to make sure my calculator's in degrees, and we just checked ours and switched it, so we don't need to do that again. But I'm going to do 1 divided by tangent of 41.2 and press enter. And we get 1.1423. And that would be our answer. Now our third example. We got cosecant of 50 degrees and 18 minutes. Now again, we don't have a cosecant button, we have sine, cosine, and tangent. But up here, I see cosecant is equal to 1 over sine. So I can rewrite this as 1 over sine 50 degrees, 18 minutes. And that's where we're going to plug in the calculator. So I'll do 1 divided by sine 50 degrees. So I'll do 50. And I'll go in my angle menu. So I do second apps. Degrees is already selected, so I'll just go ahead and put an enter on it. And then I want 18 minutes. So I'll do 18. And then I'll go into my second apps, the angle. And I want to choose the minutes, the second one. So I'll down arrow to it and press enter, or simply just press the 2 that's in front of it. And then I'll press enter. You don't need closing parentheses at the very end, unless you just want to put them. So the answer here at 4 decimal places will be 1.2997. And those are going to be our first 3 answers. Okay. Now number 4. We got cosine theta is equal to 0.24. The instructions say find each acute angle to the accuracy indicated. And we'll get down to the nearest degree here in a minute, but let's just take a look at this. So we want to find out what theta is. Well, we can take inverse cosine of both sides. If I take inverse cosine of both sides, inverse cosine of cosine, those are going to cancel. And that's going to leave us theta here. So then we'll have theta is equal to inverse cosine of 0.24. And we have inverse cosine on our calculator. Specifically, they want to the nearest degree. So we want to be in degree mode, which we are. So I'm going to come over here. You'll notice that above the cosine looks like cosine of the -1. That's our inverse cosine. So to do inverse cosine, I'm going to do my second button and then cosine and then 0.24. And then I'll press enter. And we get 76.11345,964 degrees. Now this problem is asking us to take it to the nearest degree. Well, the nearest degree would be 76 degrees. And that's our answer. Actually, I didn't want that there. Put it here. Now this next problem demonstrates something new. You see how we got arc sine? Well, we haven't seen that so far, have we? If you got inverse sine of theta, you can rewrite that as arc sine of theta. If you have inverse cosine, you can rewrite that as arc cosine. It's another way of writing our notation. And then if you have inverse tangent of theta, you can rewrite that as arctan of theta. If you have cosecant, inverse cosecant, you can rewrite that as arc cosecant of theta. If you have inverse secant, you can rewrite that as arc secant of theta. And if you have inverse cotangent, you can rewrite that as arc cotangent of theta. Okay, so that's just a different notation. I couldn't tell you why some books use this notation. Looks like -1 power, and some like to use the arcs. Okay, so this problem, we got theta is equal to arc sine of 0.4151. We'll get down to this nearest 10-minute mark here in a second. Now, we don't have an arc sine on our calculator, but I could rewrite that as the inverse sine of 0.4151. Now, specifically, it's asking us to put it into minutes, nearest 10-minute mark, which means we want degrees, which we're already in degree mode, so we're fine there. So let's go type this in. I want to choose inverse sine, so I'm going to do second sine, and then 0.4151, and press enter. Now we get this in decimal form, but this says to take it to the nearest 10-minute mark. So if I now do second apps, I can choose this fourth option. That says that we're going to convert it to degrees, minutes, seconds. So if I do enter on that and enter again, then we get this. So this becomes 24 degrees, 31 minutes, and 32.211 seconds. But this problem's asking us to take it to the nearest 10-minute mark, which means the nearest 10-minute mark, this is 31, so the nearest one is going to be 30 minutes. So our answer will be 24 degrees, 30 minutes. Okay, let's take a look at this one. Got theta is equal to inverse tangent 3.241. Now we have inverse tangent on our calculator, so we don't have to do anything special. We can just plug it in. Specifically, it says take it to the nearest minute, which implies we want to be in degree, which we are. So let's type this in. So I'm going to do my second tangent with my inverse tangent and 3.241 and press enter. And what does this say? To the nearest minute. So that means I want to convert this to degrees, minutes, and seconds. So I'm going to do my second apps to go on my angle. And again, I want to choose the fourth one that will convert it to degrees, minutes, seconds. That's DMS. Choose that and then press enter again. And we get 72 degrees, 51 minutes, 9.216 seconds. This problem says take it to the nearest minute. So we got 72 degrees, and you might be saying, well, how in the world do I do that? Well, remember there's 60 seconds in 1 minute. So if this is 30 or greater, then we'd round this up. Since this is only 9, then we're just going to keep it at 51 minutes. And that's our answer. Now these next problems revolve around some more formulas. We're given a picture here, and specifically it's asking us to solve the right triangle. So let's talk about that. And let me kind of clean this up because I don't need these formulas anymore, I don't believe. And I want to have my formulas I'm going to use and leave them up at the top here. Okay, there we go. Got this, and it's specifically got this labeled as A, it's got labeled as B, C, and theta. I don't really like these notations for labeling, because if you rotate this, if you take a reflection of it, it's hard to map out the A, B, and C. It's much easier just to approach every triangle in the manner I'm going to demonstrate here. You pick one angle to work with. Doesn't matter which one. I can pick this one or this one. You never pick the 90 degree. Once I pick that, then I try to decide this side that's opposite of it, what it would be equal to. Well, that's my opposite side. So that's pretty obvious, isn't it? The side that's opposite will be the opposite. Now this side down here, that's adjacent to the angle, so that's going to be my adjacent side. And I'll abbreviate these. And then the side that's opposite your 90 degrees is always your hypotenuse. So that's going to be my hypotenuse. Now, let me label this again. Drop some of that. I said that was B, this was A, and C. You'll see me do a mixture of these. Sometimes I'll have these letters in here, and then sometimes I'll flip them over to opposite, adjacent, and hypotenuse because it's easier to work problems to think of in those terms. But in general, this side here is side A. Notice how it's lowercase. The angle opposite of that will be our angle A, and you write that as uppercase. This side here is B. The side opposite of it is right here. This will be angle B. And the side that's opposite of this, or the angle that's opposite of this side, is right here, and this would be my angle C. Now this is always 90 degrees, so we never actually label this, but this would be angle C, and by default it's 90. Okay, if you have this kind of setup, then sine theta is going to be equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. And tangent theta is going to equal to opposite over adjacent. Now those are the three popular ones to use. But you can also define some relationships for cosecant, secant, and cotangent. Now sine and cosecant are reciprocals of each other. So if sine is equal to opposite over hypotenuse, then cosecant will equal to hypotenuse over opposite. Cosine and secant are reciprocals of each other. So if cosine is equal to adjacent over hypotenuse, then secant will be hypotenuse over adjacent. And tangent and cotangent are reciprocals of each other. So if tangent is equal opposite over adjacent, then cotangent will equal to adjacent over opposite. Now, one thing in addition, the Pythagorean Theorem, if I can spell it, the Pythagorean Theorem says, if you think of it back in terms of A, B, and C that you saw back maybe in geometry, that's A squared plus B squared is equal to C squared. In terms of our opposite, adjacent, and hypotenuse, that's adjacent squared plus opposite squared equals hypotenuse squared. So these are all our formulas we're going to use to work these problems. So let's take a look at our first one, number 7. They tell us theta is 32 degrees, 20 minutes, and C is equal to 13 centimeters. And let me draw my picture. They give you a picture, you might as well use it. Like that, then B, and then A, and then C. Okay. Now solving a triangle, it means finding all of your angles and sides. So what we're looking for this problem is we want to know what A is, we want to know what B is, we want to know what C is, those are all uppercase A letters, and we want to know what side A is, side B, and side C. Well, they give us this one. C is 13 centimeters. Remember, by default, angle C is always 90 degrees. They also tell us that theta, which is right here, which is opposite side B, which means that's angle B. That's going to be 32 degrees and 20 minutes. Okay. First off, let's find angle A. Now, all of the angles inside of a triangle add up to 180 degrees. So, there's a couple formulas you could use here. A is going to equal to 180 degrees minus B minus C. Or you could simply just do A is equal to 180 degrees, or A is equal to 90 degrees minus angle B. So it doesn't matter which one. I'll use this one. So we got A is equal to 180 degrees minus B. Well, B we said was 32 degrees, 20 minutes, minus C, and we said C was 90 degrees. And let's plug that in the calculator to see what we get. So I got, I think I'm in degrees. Let me press mode just to verify. Yeah, degrees. So do second mode to exit out. Second mode to exit if you have anything. Then I'll put in my 180 degrees. So I do 180 go to my angle menu, do enter on degrees, minus 32 degrees. Again, I'll go to my angle menu to get the degree mark. And then 20 minutes. Again, I'll go to the angle menu, second apps. And I'll choose minutes, which is the second one. Minus 90 degrees. Again, second apps, then enter on degree, and enter again. Now we got decimals. Probably don't want decimals since our original angle had minutes. So let's go ahead and do second apps, and we're going to choose number 4, which will change it to degree, minutes, seconds. And then press enter. So it looks like this will be 57 degrees and 40 minutes. So that's 57 degrees and 40 minutes. Okay, let's find side A. Now, in terms of our angle here, let's draw the picture. This angle here is B, which was 32 degrees, 20 minutes. Now we're also given C, which is right here, which is the hypotenuse. So they're specifically telling us the hypotenuse is equal to 13 centimeters. Now we're trying to find A, which was, we said, was the bottom row here. Well, this bottom row in terms of this angle here is our adjacent side. So we're trying to find that right there. Okay. Well, I have adjacent and hypotenuse. So if I come up here to my 3 formulas, I'm looking for the one dealing with adjacent and hypotenuse. Well, cosine theta is equal to adjacent over hypotenuse. Now secant is also, but remember we don't have a button on the calculator to help us with secant. So we always want to go with these first 3. So cosine theta is equal to adjacent over hypotenuse. And let's plug in the values. So we got cosine of 32 degrees, 20 minutes is equal to adjacent, and remember that was A, so I'll go ahead and put A there, over hypotenuse, which is 13 centimeters. Now we're trying to get A by itself, so I'm going to multiply both sides by 13 centimeters. So I got 13 centimeters times cosine 32 degrees, 20 minutes is going to equal to A. Okay. So 13 times cosine 32 degrees. So do 32, go to my angle menu, do enter on degrees. 20 minutes, so do 20, go into my angle menu, choose minutes, enter, and enter again. And I'll take these 3 decimal places. But you'd do whatever the instructions said on the homework or test. So we got A is equal to 10.984. And this will be in centimeters. Okay, well now we know what side A is. Side A is 10.984 centimeters. Well, now we need to find B. And let's draw a picture again. We're given this angle here, which is 32 degrees, 20 minutes. We're told the hypotenuse, side C, is equal to 13 centimeters, so that still remains. But this time we're trying to find angle B, or side B, sorry, which is this side over here. In relation to this angle, this side over here is the opposite side. So we're trying to find this. So we got opposite and hypotenuse. So if we come up to our formulas, we're looking for one in these first 3 that deal with opposite and hypotenuse, which is our first one, sine. So sine theta is equal to opposite over hypotenuse. So let's plug in what they give us. The angle is 32 degrees, 20 minutes. Opposite, we don't know, but it's actually letter B, so let me put a B in there, just make it a little bit easier to see. And hypotenuse, we said, was 13 centimeters. Now we want to solve for B, and just like the previous problem, we're going to multiply both sides by 13 centimeters. So we'll take 13 centimeters times sine 32 degrees, 20 minutes, and that's going to equal to B. So I got 13 times sine 32 degrees. So I do the 32, do second apps from my angle menu, enter on degrees, 20 minutes. So do 20 and then do second apps and choose minutes and then press enter. And I'll take it again to 3 decimal places. So I got B is equal to 6.953. It was 952, but since this was 5 or greater, I rounded up and this became a 3 centimeters. So we got 6.953 centimeters. Now our goal was to solve the right triangle, and that means finding all the angles and all the sides, which we just did. Now, one thing to keep in mind is your largest angle should have the largest side. So here's the largest one, 90 degrees, and it does have the largest side. Your smallest angle, which is our 32 degrees, 20 minutes, should have the smallest side, which it does. So that's kind of a very quick check you can do to see if you came up with reasonable results. Let me go ahead and clean that away, and then we'll look at the problem number 8. Now I'll leave the original formulas up at the top. There we go. So let's see what problem number 8 is. And actually, let me grab a drink here. Okay. This says we got theta is equal to 15.3 degrees and B is equal to 4.71 centimeters. Now remember our goal in solving a triangle. We want to find angle A, angle B, angle C. Angle C is always our 90 degrees. Side A, side B, and side C. B they're giving us, that's 4.71 centimeters. And theta, well, if I look at my picture they give us, so if I sketch this down, this will be theta. And it's a little bit confusing because they use a mixture of A, B, and C sidewise with theta as an angle. Remember what I mentioned earlier. If this is side B, then the angle that's opposite of it, which is this right here, should be angle B. So this is theta is the same as B. So when they give us this, they're giving us B. So this is 15.3 degrees. Okay, first thing we want to do is we want to find angle A. And I'm going to do this a little bit different. To find angle A, you can take 90 degrees minus B. Because I know automatically that angle C is always going to be 90 degrees. So these other two have to add up to 90 degrees. So A is going to equal to 90 degrees minus 15.3 degrees. So 90 minus 15.3. 74.7. So this right here is 74.7 degrees. Okay, now let's find side A. And notice uppercase A versus lowercase a. Uppercase A is the angle, and again, lowercase a is the side. Well, let's write down our triangle and see what in the world they give us. Then we'll go from there. Now they're telling us that this angle here is 15.3 degrees. They're also giving us side B. Side B is this side here, which in terms of our angle is the opposite side. So they're telling us that the opposite is equal to 4.71 centimeters. Now we said we're trying to find side A in this one, which is this bottom piece. Well, side A is going to be our adjacent with regards to this angle. So we're trying to find adjacent. Now I come up here, look at my formulas. I'm looking for something dealing with opposite and adjacent. Tangent. Tangent has opposite over adjacent. So tangent would be a good choice to use. So tangent theta, oops, kind of sloppy. Tangent theta is equal to opposite over adjacent. So we got tangent of 15.3 degrees is equal to opposite, which was 4.71 centimeters, over adjacent, which was, remember, side A. It's easier to work with A instead of writing adjacent there. Now we want to solve for A. So we want to multiply both sides by A. So I'll take A times tangent. So we got A tangent 15.3 degrees is equal to 4.71 centimeters. And then we're trying to get A by itself, so we're going to divide both sides by tangent 15.3 degrees. Because remember, tangent 15.3 degrees is just simply a number. And so we'll get 4.71 centimeters over tangent 15.3 degrees. This tangent 15.3 degrees is going to cancel. It's getting hot in my room here. It must be getting cool outside. And A is equal to, and I'll type that in my calculator, 4.71 divided by tangent 15.3. And I'm in degrees, so we're fine there. So we get A is equal to 17 point, and I'll take it 3 decimal places, 2.17 centimeters. So we now know what A is. What did I say it was? 17.217. 17.217 centimeters. Okay. Now you might think, well, use a Pythagorean theorem to find C. That's easier than what you're using. Yeah, but side A is an approximation. I rounded it, didn't I? Even if I had kept all these decimal places you see here, it'd still be an approximation. When we're solving triangles, we try to, as much as possible, use exact values. Since this was an approximation, I'm not going to want to use that unless I'm forced to. So let's see if there's another way to find C. Okay, so we're going to find C. And let's write down our triangle again. We said this angle here is 15.3 degrees. They give us B, which is the opposite side, so they're telling us opposite is equal to 4.71 centimeters. And we're trying to find side C, which according to our picture they give us is the side that's opposite our 90 degrees, which also happens to be our hypotenuse. Okay, so we're looking for a formula dealing with opposite and hypotenuse. Our first one works, opposite over hypotenuse. So we're going to work with sine theta is equal to opposite over hypotenuse. So let's plug in what we're given. So we got sine of 15.3 degrees is equal to opposite, which is 4.71 centimeters, over hypotenuse, which we said was side C. Now we want to solve for C. So multiply both sides by C, and we get C sine 15.3 degrees is equal to 4.71 centimeters. And we're going to divide both sides by sine 15.3 degrees. There we go. and 4.71 centimeters divided by sine 15.3 degrees. Over here, these sine 15.3 degrees will cancel, and we're left with side C is equal to 4.71 divided by sine and then 15.3, and then press enter. If you're getting different values here when you're plugging in the same thing, probably means you're in radians. So I get 17 point, I'll take it 3 decimal places, 849 degree, or not degrees. What are we doing with centimeters? Okay. So C is equal to 17.849 centimeters. And if I just do the quick little check, our largest angle is angle C, and it's the largest side. Our smallest angle is B, and it's the smallest side. So these numbers do seem reasonable. So those would be our answers. Now let me go ahead and clear that problem out, and we'll look at number 9. Eventually. There you go. Okay, so number 9. We got theta is equal to 42.9 degrees. Little a is 11.35 centimeters. And again, we're solving the right triangle, so what we're trying to do is we're trying to find A, B, C angle-wise, and side A, side B, and side C. Well, they're telling us A, that's 11.35 centimeters. And if I draw the picture that they give us, this is theta, this is side B, side C, and side A. Okay, that's all the information. Now, again, it's a little bit confusing. They got this labeled as theta, but we know that the angle that's opposite this side, if this side's little b, then this will be angle B. So theta is the same as angle B. So they're telling us this is 42.9 degrees. Now C, here's side C, so the angle opposite of it, which is this right here, is our 90 degrees. So that's by default 90 degrees. Okay, so first thing we want to find is we want to find angle A. And I'm going to use the formula A is equal to 90 degrees minus B, because if this is 90 degrees, these other two angles have to add up to 90. So I got A is equal to 90 minus 42.9. I'm not very good with decimals, but let me try it. 47.1. 989. Yeah, 47.1. Okay, so now we need to find our sides. So let's find side B. Now let's draw the picture. See what they give us. They give us theta, which is right here, which is 42.9 degrees. They're giving us A, which is this bottom side, which is our adjacent to that angle. So adjacent is 11.35. And we're trying to find B, which is this side opposite of this angle. So this will be opposite. So we're looking for a formula dealing with opposite and adjacent. If I come up here, that's this one here. Tangent theta is equal to opposite over adjacent. So tangent theta is equal to opposite over adjacent. So plug in everything that's given. So we got tangent 42.9 degrees is equal to opposite, which we said was B, over adjacent, which was 11.35 centimeters. I didn't put the unit measure there, but that should be centimeters. Now we're trying to solve for b, so we're going to multiply both sides by 11.35. So take 11.35 centimeters times tangent, 42.9 degrees, and that's going to equal b. So 11.35 times tangent, 42.9, and it is in degrees, so we're fine there, and I'll press enter. And I'll take it 3 decimal places. So we got b is equal to 10.547. 10.547, and what is it, centimeters? 10.547. 10.547. 10.547 centimeters. Well, now we need to find side c, so lowercase c. Let's draw our picture, see what we're given. Here's our 42.9 degrees. They're giving us the adjacent, which is this side. So adjacent is equal to 11.35 centimeters. And we're trying to find c, which c is this side here, according to our picture, which is our hypotenuse. So we're trying to find our hypotenuse. So it looks like we're looking for a formula dealing with hypotenuse and adjacent. Well, here's cosine. Cosine is equal to adjacent over hypotenuse. So cosine theta is equal to adjacent over hypotenuse. So let's plug in what they give us. They tell us the angle is 42.9 degrees. Adjacent is 11.35 centimeters. And hypotenuse is c. So I'll put c there. Now we're trying to solve for c, so we'll multiply both sides by c. So we get c times cosine 42.9 degrees is equal to 11.35 centimeters. Then we're going to divide both sides by cosine 42.9 degrees, and we get c is equal to 11.35 centimeters divided by cosine 42.9 degrees. Okay. 11.35 divided by cosine 42.9. Enter. I don't need to put a degree mark on that because I know I'm already in degrees, so that's beneficial. I'll take this 3 decimal places. 15.494, rounded up, centimeters. This is assuming my eyes are seeing all this. Okay, my eyes aren't very good. 15.494 centimeters. Becoming more and more like Mr. Magoo. Now our largest angle is 90 degrees, and it should have the largest side, which it does. Our smallest angle is at 42.9, and it should have the smallest side, which it does. So it seems like a reasonable answer. Okay, so let me clear that out, and we'll take a look at problem number 10. These problems take a little bit. Okay, so problem number 10. We got this one. We're given B is equal to 71.2 feet, and C is equal to 121 feet. And solve the triangle, and then angles the nearest 10-minute mark. So we'll talk more about that here in a second. Remember what we're trying to find. We're trying to find angle A, angle B, angle C. Angle C is 90 degrees, so we got that one already. Then side A, side B, and side C. Well, B, they're telling us, is 71.2 feet, and C is 121 feet. Now, first thing we'll do is we'll find A. Because we can use the Pythagorean Theorem. So we got our A squared plus B squared is equal to C squared. I didn't draw my picture, did I? Okay, I'm drawing a picture. That'll demonstrate why we can do that. This is C, this is B, and this is A. And Pythagorean Theorem says this side squared plus this side squared is equal to the hypotenuse squared. Okay, so A we don't know. So we got A squared plus B squared, which is 71.2 squared, is equal to C squared, which is 121 squared. So we got A squared is equal to, and I'll take that over. So we got 121 squared minus 71.2 squared. Square root property from college algebra. We'll drop our squared, and we put a plus or minus square root on the other side, but I'm just going to put a square root. The reason why that we just put a positive version of it is because remember what we're finding. We're finding the length of the side, and negative distance doesn't make any sense. Now this is an exact answer at this point. So if you want to use this further in calculations, this is what you'd want to use. But I'm going to find an approximation to 3 decimal places. So we got square root. So I do second x squared. And then we got 121 squared minus 71.2 squared. And then press enter. And that gives us 97.834. And what are we dealing with? Feet. I didn't keep the units of measure throughout there, but we knew what the unit measure was going to be. So this would be 97.834 feet. Now keep in mind, this here is an approximation. So this is an approximation. This here is an exact value, and this here is an exact value. So when I'm working problems from here on out, I do not want to use A because it's an approximation. As much as possible, you stick to only using the exact values. Okay, so let's find the angle A. So if I draw my picture, here's A, B, C. Angle A. Well, if this is side A, angle A would be this angle that's opposite of it. Okay, so this is what we're trying to find. Now, in relation to this angle here, this side is going to be opposite. And B is going to be adjacent. And C is always hypotenuse, so you don't need to worry about that. So whenever you pick an angle, your opposite and adjacent will sometimes change. Okay, now let's plug in the values they give us and see what we got. And let me scroll down a little bit. This is what we're trying to find. And they tell us B, which B is our adjacent side. So they're telling us adjacent is 71.2 feet. And they're telling us C, which is our hypotenuse. So this is going to be 121 feet. And that's also our hypotenuse. Okay, so we're looking for a formula dealing with adjacent and hypotenuse. Well, this is cosine. Cosine of our angle, which is A in this case, is equal to our adjacent over the hypotenuse. And let me show you where I got that from just so you can see it. Okay, again, look at these first three here. Adjacent over hypotenuse is cosine. All of our previous examples have had the angle down here, but it does not matter where you work with the angle. If you choose this to be the angle, the only thing that changes is your opposite and adjacent sides. Okay, so we got cosine of A is equal to adjacent, which is 71.2 feet, over hypotenuse, which is 121 feet. Now the feet are going to cancel there. And we got cosine A is equal to 71.2 over 121. Now we're going to take inverse cosine of both sides. So we got inverse cosine of cosine A is equal to inverse cosine of 71.2 over 121. Reason why we take inverse cosine of both sides is because inverse cosine and cosine cancel each other away. So that's going to tell us that A is equal to inverse cosine, so I'll do second cosine, 71.2 divided by 121, and press enter. Now specifically, they're wanting it in the nearest 10-minute mark. So let's change this to degrees, minutes, seconds. So I'll do second apps, choose number 4, and then press enter. Now this is 57 minutes. So the nearest one is a 60-minute mark, but 60 minutes is equal to 1 degree. So that'll be 54 degrees. That one comes out nice. So that's 54 degrees. Now we need to find angle B. And I could do the same setup here. B, if this side is B here, then angle B will be over here. So that's what we're trying to find. Now they're telling us in this problem B is equal to 71.2. B is this side here, which in terms of this angle is the opposite side. So the opposite side is going to equal to 71.2. Hypotenuse never changes. It's always the side that's opposite your 90 degrees. So hypotenuse is 121 feet. So we're looking for a formula dealing with opposite and hypotenuse. Well, here's an opposite and over hypotenuse, so we're going to work with sine. So we got sine theta, though I don't want theta, do I? Because what's my angle? B. So sine B is equal to opposite over hypotenuse. So I got sine B is equal to opposite, which is 71.2, over hypotenuse, which is 121. My feet would cancel, so I went ahead and dropped those to begin with. Now I can take inverse sine of both sides. So inverse sine of B is equal to inverse sine of 71.2 over 121. Reason why we take inverse sine is, again, inverse sine and sine are going to cancel each other. And we got B is equal to inverse sine, so I'll do second sine, 71.2 divided by 121. And then press enter. And I'll take it, I won't take it to anything. It tells us take it to the 10-minute mark. So I need to change this to degrees, minutes, seconds. So I'll do second apps. I want to choose number 4, so I'll press 4. And that'll convert it to degrees, minutes, seconds once I press enter. So we got 36 degrees, 2 minutes. So the nearest 10-minute mark is a 0 minutes. So this will go down to 36 degrees. So this will be 36 degrees. Now, another way I could have found B is once I found A, I could have simply just subtracted that from 90 degrees. Now, you might be looking at that and say, well wait a minute. I thought you said this is an approximation because we rounded it, and you never want to use an approximation if you can help it. That's true normally, but since you'd like all these angles to add up to 180 degrees total, then it doesn't do any harm to use an approximation in that regard. But you wouldn't want to use approximation normally. If you can use exact values, that's typically what you go for. Okay. Let me clear out that problem, and then we'll look at number 11. The rest of the problems aren't as long as those. Those get kind of long. There we go. Number 11. Let me grab a... Oh no, solve another right triangle. I just showed one of those. I guess there's no use to show another one. I'm not sure why I have so many of those. Okay, let's take a look at number 12. Let theta be an acute angle of a right triangle for which cosine theta is equal to 2/5. Now specifically, they're telling us to then find tangent theta. Although we could find all 6 of these, which you may have a homework assignment that asks you that. They give you one of them, and then they ask you to find all the rest. Well, let's see how to do this. They're telling us that cosine is equal to 2/5. But if I look up here, cosine is equal to adjacent over hypotenuse. So they're telling us that adjacent is equal to 2, and they're telling us the hypotenuse is equal to 5. Okay, so adjacent is equal to 2, and hypotenuse is equal to 5. Now, we need to find all 3 of them, the adjacent, opposite, and hypotenuse. So we're going to use Pythagorean Theorem here. So we got our adjacent squared plus opposite squared is equal to hypotenuse squared. Adjacent was 2, so we got 2 squared plus opposite squared is equal to hypotenuse squared, which is 5 squared. 2 squared is 4 plus opposite squared is equal to 5 squared is 25. I'm going to take the 4 over, so I got 25 minus 4. 25 minus 4 is 21. And then for our opposite, we're going to drop our squared, and we'll put a square root on the other side. Now, we don't put a plus or minus, because again, opposite implies a measure of that side. And distance can't be negative in this regard. Okay. So that's our opposite. Well, how does that benefit us? Well, up here we said tangent is equal to opposite over adjacent. Well, where in the world does that come from? Okay, opposite over adjacent. Well, we just said opposite was square root of 21. And we just said adjacent was 2. So this would be what tangent is equal to. Now, even though this problem isn't asking for it, let's go above and beyond on this. Let's find the other different ones. Now, cosine's given, so I don't need to find it. But sine. Sine is going to equal to opposite over hypotenuse. Opposite is square root of 21 over hypotenuse, which was 5. So that would be sine. Now, these are the 3 main ones: sine, cosine, and tangent. Once you have those, then the cosecant, secant, and cotangent are these flipped. Flipped. What in the world do I mean by that? Well, cosecant. Cosecant is going to be sine flipped. These go hand in hand. So flipped means reciprocal. So I'm going to take this fraction here, and I'll rewrite it as 5 over square root of 21. Now, we can't have a square root in denominator. So we're going to multiply top and bottom by that square root. You always do that. Whatever that square root is here, you multiply top and bottom by it. Which then gives us 5 square root of 21. And square root of 21 times square root of 21 gives us 21. Okay. Now we have cosine. So secant is just cosine flipped. The reciprocal of it. Well, cosine is 2/5, so secant will be 5/2. Now, cotangent. Tangent and cotangent go together. Cotangent is simply tangent flipped, the reciprocal of it. So I'm going to take square root of 21 over 2 and rewrite it as 2 over the square root of 21. And again, we can't have a square root down in the denominator, so I'll multiply top and bottom by the square root of 21. And that gives us 2 square root of 21 over 21. So that's how you'd find all of your trig functions given one piece of information like that. Okay. Let's let me clear that out, and we'll look at problem number 13. Okay, problem number 13. Let me do it up here, I guess. Let's see. Let theta be an acute angle, right triangle for which tangent is equal to 7/2. And they want us to find cotangent. Well, if they give you these pairings, like sine and cosecant, cosine and secant, or tangent and cotangent, remember these are just reciprocals of each other. So if tangent is 7/2, cotangent will be 2/7, and that's our answer. Okay, problem number 14. They're telling us that cosecant is equal to 5/3, and we're wanting to find tangent. Well, these are definitely not reciprocals of each other, so I can't use that. But if I look at cosecant, this tells us that cosecant is hypotenuse over opposite. So they're giving us the hypotenuse, and they're giving us the opposite. So let me come down here. Hypotenuse is equal to 5. Opposite is equal to 3. And we need to find out what adjacent is. So we're going to go to our Pythagorean Theorem again. So we got adjacent squared plus opposite squared is equal to hypotenuse squared. So we got adjacent squared plus opposite is 3. So we got 3 squared equals hypotenuse squared, which is 5 squared. So we got adjacent squared plus 9 is equal to 25. I want to get the adjacent squared by itself, so I take the 9 over. It becomes 25 minus 9. So we got adjacent squared is equal to 16. Yeah, 16. Now we'll drop our squared, and we'll put a square root around the other side. That's a square root property, or a variation of it from college algebra. Now 16 is 4 times 4. And remember with square roots, we're looking for a pair of somethings. So here's a pair of 4s. They're going to come out in front as a single 4. So we got our adjacent is equal to 4. Now if you had spotted this as your standard 3, 4, 5 triangle, then you would have saved yourself a lot of work. Okay. Now that we have these 3 items, then we'll go back to what we're trying to find, tangent. And tangent says it's opposite over adjacent. So it's equal to opposite over adjacent. And opposite we said was 3. And adjacent we said was 4. So tangent is going to equal to 3/4. And that's going to be our answer for that particular one. Now I'm going to clear off my screen here, and then we'll take a look at something new. It varies away from these these formulas here. So I'm going to erase the entire thing, I believe. There it goes. And they're introducing something that we're going to see a lot more in coming sections. And they talk about specific angles that mean something. Specifically, we're focusing, this is going to be called something called the unit circle. And it's a complete circle here, but I'm just going to look at the first quadrant. Now, this was 90 degrees, and this was 0 degrees. If you remember from our angles. So 0 degrees, 90 degrees, over here is 180, down here is 270. Now halfway up here is 45 degrees. About right, I'm just guessing right there, is 30 degrees. And I don't know, somewhere right here is 60 degrees. Now, we don't want to think too much on this. But our point here is going to be 1, 0. We're going to explore this in a lot more depth when we talk about the unit circle. This point right here is going to be square root of 2 over 2 and square root of 2 over 2. This point here is going to be 0, 1. And when I say point, we would put this on XY axis and we'd see what these points are. And when I say what these points are, I'm talking about here, 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 and here. Now this one here is going to be the square root of 3 over 2 and 1/2. And this point here is going to be 1/2 and square root of 3 over 2. Okay, now we also have something similar for radians. This is 0 degrees. In radians, that's still 0. 90 degrees is equal to pi over 2. At this 45 degrees, this is going to be pi over 4. At 30 degrees, this is going to be pi over, and let me think this through, pi over 6. And then at 60 degrees, this will be pi over 3. Now we got some more formulas that go along with this. Sine theta, this is assuming you're working with a unit circle, these special angles here. Sine theta is going to equal to y. Cosine theta is going to equal to x. Tangent theta is equal to y over x. Cosecant is a reciprocal of sine, which would be 1 over y. Secant is a reciprocal of cosine, which would be 1 over x. And cotangent, a reciprocal of tangent, which would be x over y. X and y. What in the world am I talking about there? Well, when you're looking at these points here, this would be your x part, and this would be your y part. And the same in all of these. So that's where we're talking about with the x and y. And clear as mud. It will be, hopefully after we look at these examples, it'll become clear. So the first one here, 15. It tells us we got cosine 30 degrees minus tangent 60 degrees. It says find the exact value of each expression, which means don't plug it in your calculator. Pretty much throughout this entire course, we like exact values. Okay, 30 degrees. 30 degrees is right here. Cosine is our x part. So here at 30 degrees, the x part of our point is going to be square root of 3 over 2. So we're going to replace cosine 30 degrees with square root of 3 over 2. Minus tangent 60 degrees. Well, here's 60 degrees. Tangent is equal to y over x. So here at 60 degrees, this is x and this is y. We're going to put this y value over the x. So we got square root of 3 over 2 all over 1/2. Okay, we got square root of 3 over 2 minus, when you have a single fraction over a single fraction, they both have the same denominator, you can cancel those denominators out. So those 2's would cancel away, and we'd have square root of 3 over 1. Now we want to get a common denominator. And our least common denominator would be 2, since this is 1. Now this one already has a 2, so we leave it alone. But on our second fraction, we multiply the bottom part by 2, so we have to multiply the top part by 2. So this becomes 2 square root of 3. Now that they have the same denominator, I'll add or subtract the numbers that are out on top. I'll learn to speak someday. Now remember, there is no number before this square root of 3, so remember there's a 1 there. So we got 1 minus 2, which gives us negative 1 square root of 3 over 2, or simply negative square root of 3 over 2. And that would be our answer. Let's look at the next one. Let me clean that up. And problem number 16. We got tangent pi over 3 tangent pi over 2 minus cosecant pi over 4. Okay, pi over 3. Where's pi over 3? Pi over 3 is right here. So we're working with this set of this point right here. Now tangent is y over x. And remember, since we're working with this point, this is our x and this is our y. So y over x, we're going to have square root of 3 over 2 all over 1/2. Now tangent of pi over 2. Here's pi over 2. Oh, that's just great. I made this example up, but this is x and this is y. This would be 1 over 0. What happens when you got 0 in the denominator? It's undefined. I didn't mean to make that one that easy. But if this had worked out nice, I'd go here to cosecant. Cosecant is cosecant of pi over 4, which is right here. So we're going to be working with this point here. Cosecant is 1 over y, and our y is square root of 2 over 2. So we'd have 1 over square root of 2 over 2. Well, let me change that. Let me change that. I don't like the fact that I got a bogus problem. Let me put a 0 there instead. Okay, tangent 0. There we go. And okay, so tangent 0. Well, here's 0 degrees here, and tangent is y over x. So this is x, this is y, so we'll have 0 over 1. Still doesn't come out like I originally planned, but that's okay. Because I could care less what this is equal to, because 0 over 1 is 0, and 0 times anything is 0. So that's a big 0 in this first part. Now, whenever you have a single fraction in your denominator, you can always flip it and multiply times your top part. So we'll flip this, take the reciprocal of it, which is 2 over square root of 2, and multiply times the 1. 0 drops away. Negative 1 times 2 gives us negative 2 square root of 2. Now we can't have a square root in the denominator, so we'll multiply top and bottom by that square root. So we've got negative 2 times square root of 2 over square root of 2 times square root of 2, which gives us negative 2 square root of 2, and square root of 2 times square root of 2 is 2. Those 2's will cancel, and our answer is negative square root of 2. It came out nice once I changed it. Okay. Let me change it here. 0. There we go. Now our last problem is this right here, and I just want to demonstrate this. We've been looking at a lot of degrees, but let's take a look at how to do a radians. And this is nothing more exciting than to plug this in the calculator and take it to 4 decimal places. I know it's radians because it doesn't have a degree mark. So on my calculator, I'm going to go switch it to radians. So press my mode, down arrow to the radian degree line, I press enter on radians. Exit out, so do second mode, and then I'll do tangent and pi over 7. So do pi, divide by 7, and press enter. The 4 decimal places will have 0.4816. And that's our answer. And into that lesson.